All right, we'll just go ahead and start. Today we're going to finish up strings by talking about data processing with strings. And data basically is fundamental to CS. We have a brand new major and an emerging discipline called data science as a subdiscipline of computing. So that tells you how important it is to process data. And that means that's why we've been covering strings, because strings are used to store data, right? It's not always necessarily for human consumption, right? It's not necessarily, here's my novel and here's my paragraph, my sentence or whatever. Instead, it can be stored in a textual manner, but for humans in a readable format, or it can be stored in a format designed for a computer, right? More often, data is stored in a structured format. And some of those formats are going to be XML, for example. That stands for extensible. Here, I'll go with X there. Extensible markup language, right? That's where the X comes in. We didn't want to call it EML, apparently. X sounded cooler, and so that's why we went with XML or something. JSON, which is more lightweight XML. It stands for JavaScript Object Notation. JavaScript Object Notation, right? And we can look at a couple of examples of these. I don't know here. In fact, you'll do so in one of your labs in the coming weeks here. But XML example, right? So an XML example here is going to have basically what are called tags. Give me a substantial example. Fine, example. All right, here's an XML file. All right. View page source, because of course my browser is not going to show that. So let me go ahead and zoom in here, and you see that we've got these things called tags that are surrounded by Langle wrangles. That is a note, and then how do we know that the data ends? We have a closing tag with Langle wrangle, but a / here, right? That is a /. Inside of that, we've got other pieces of metadata. For example, in the note, we have who it's to, who is it to, who is it from, what is the heading? What is the body? And inside of each of one of those tags, we have data that looks something like this, right? Now, if I took the same exact thing and translated it to JavaScript object notation, JSON, or let's XML to JSON. There are converters all over the place. You'll probably use one at some point. That's the best one, apparently. There we go. Let's go ahead and do that. And then XML to JSON. There we go. It's the exact same data, but it's formatted in a little bit of a different way. You'll note here that we don't have opening and closing tags. Instead, we just have this key value pairing. So the note, and then we've got a colon here, opening and closing curly brackets. Within that, we've got all this. And this is why it's considered a little bit more lightweight, because this note is not repeated down here. Now, that doesn't matter if there's one record, but what if there are 1 million records in this file? The note, 1 million notes. The note is repeated 2 million times, one for the beginning tag, one for the closing tag. Whereas here, it's just once, right? So it's lighter weight. It's going to be easier to send over the network, and that's why JSON is probably the de facto this is all called EDR, electronic data interchange, or EDI, sorry, electronic data interchange, where you're sending data, structured data, from one computer to another over the network. This computer can be programmed in C. This computer can be programmed in Java, and they still need a way to communicate with each other. And with these universal formats of data are how it's done, right? There are other ways of doing this, right? Those aren't necessarily meant for human consumption, because you're not going to have grandma reading her Facebook feed or whatever it is with a bunch of XML like this. Nor are you going to have them, as an end consumer, want to see something that looks like this. They want to see the note all nicely formatted in HTML and stuff like that. And so these are not meant for human consumption. A couple of others that are a little bit closer to human consumption but still meant for a computer are TSV and CSV. These are tab separated values, or what is CSV? What do you think? C stands for computer. This is with respect to the delimiter. So a comma delimited or a separated value file. Okay. Here's a really quick example. Right? I've got a string here that represents one piece of data. I don't have any tags here at all. I'm not saying what these things are. That's the difference between CSV data, which is a little bit less structured, versus XML and JSON over here. Everything is semantically marked. That is, if you wanted to find out who this is to, all you need to do is look at the tags. Right? This tag tells me who it's to. This tag tells me who it's to. So staring at this data, if you know who this person is or what this is describing, then you might understand what it is. But without those tags, I'm going to have to tell you. Although I'll ask, does anybody know Terry Pratchett? No big readers out there? Okay. So Terry Pratchett, now deceased. Sir Terry Pratchett is English and was knighted. His first name is Terry. His last name is Pratchett. And one of the first books that he wrote in fact, it was the first book in the Discworld series, was called Color of Magic. And you know he's British because color is spelled that way, right? This is also data that I pulled off of Goodreads.com, right? That tag, now that you know it's a book and that's the author, what do you think that number there stands for? A year, the year that it was released and published. This last one, however, I'm going to have to tell you what that is. That's the average Goodreads rating, which is out of 5. Okay, it deserves to be a lot higher, but I won't quibble. Right? So each one of these pieces of data has a semantic meaning, but we don't have any tags in this data telling us what it is. That's okay. We can still work with it. How do I know, though, that there are 5 pieces of data? How are they separated? Commas, right? And that's the semantics in comma-separated value files. With a tab-separated value file, what would be the thing separating them? A tab, right? You could also have colon separated values or semicolon separated values or whatever, right? This is what's called a basic flat file representation, right? TSV, CSV. In fact, to an extent, XML and JSON are too. Basically, the data has been flattened. I've got a lot of stuff represented there. I've got a year. I've got a person, which is a first name and a last name. I've got a book. I've got the title of the book and the rating of the book. I've got a lot of related data, and in computer science too, you'll learn how to relate that data using a relational database management system. We're not there yet. Instead, what we've taken is we've taken all this related data and we've squashed it down to a flat file. We've just taken these 5 pieces of data and put them into one string separated by commas, right? And that is extremely common. In fact, if I put this into a file and name that file mybook.csv and I double clicked on it, what do you think would open up? Have you ever tried to open up a CSV file before? Right? Excel would open up. Why? Because it sees that it's a comma separated value file and, well, this is the first one, so it belongs in the first column. This is the second one, it belongs in the second column. Third column, fourth column, etc. In other words, this is columnized data, right? This is the first column, the title. The second column is the author's first name, etc. There's just no semantic meaning to it. All right, so my goal for today is to process this data. And that's called tokenization, right? Basic tokenization. We're going to split this string up into data into separate tokens. The first column, second column, third column, fourth column, fifth column. And we'll process each and every single one separately, right? That's called tokenization, okay? C provides a function to do this called strtok, short for string tokenization or tokenizer. Right? Here is the function's signature. Right? Now we're going to go through each one of these separately, but I will draw your attention to the fact that it takes a string, it takes another string that is const, and then it returns a string. So all of these values are strings. Right? The first one is the string that you want to tokenize. The second one is the delimiter that you want to use, because we're not always going to have CSV data. Sometimes you're going to have TSV data. Sometimes you're going to have colon separated data, right? And so you can change and provide a custom delimiter here, okay? All right, so what's the first argument? As I said, it's the string that you want to tokenize, right? Careful. What is absent? That's how you spell. Yeah, absent from the first argument. Const. There we go. What does that mean? What should that be telling you? It can change, and if it can change, then it does change, right? The strtoke is going to change your data. Right? It's going to change your string. Right? If you do not want that, what's the solution? I can't change the library, right? Because that was already written. I don't want to touch it anyway. Right? So we'll do what? Put a copy in. Right? Make a completely separate copy and go ahead and process the copy. We call that what kind of copy? Deep copy. Exactly. So the solution, process a deep copy instead. Right? If you don't want it changed. If you don't care about it changing, fine, whatever. The second argument is a string, which is a delimiter that you want to use, right? For us, we'll use a comma. Now note there that that's not a single string. I put in double quotes, right? In fact, if I put in single quotes that I only want one delimiter, it would actually not compile because that function requires a string as its second argument. The reason for us is it is also possible to use multiple, right? For example, comma and semicolon and colon and a space or something. And what that'll do is it'll use all four of those things as a delimiter if you're processing more complex data, right? We'll ignore this though. We'll ignore this feature, right? Because for us, we're only interested in CSV data for now. Because at the end of the day, CSV data is actually more complex than it seems. This seems really, really simple. But what if my data, color, blank, comma of magic, what if my title had a comma in it? Yeah, then I'd kind of be screwed, right? Basically, I would have to escape it. Okay, well, what if my title had a backslash in it? Then I'm going to have to escape that. What if it had a double backspace or a backslash or whatever, right? No, right? If you really want to process CSV data in the real world, bring in a library to do it, right? We're going to use this just as a simple example to show you how string tokenization works, right? If you were to do this in real life, definitely bring in a library, okay? All right, what does it return? It returns a string pointer, right? A pointer to a character array, which we call strings. It returns a pointer to the next token, i.e. you need to call this function several times to get each one of the tokens, right? How do I know that it's done? When no more tokens are available. And what by that I mean, I'll call it once to get the title of the book. I'll call it twice to get the first name. Call it 3 times. The third time gives me the last name. How do I know when it's done? When there are no longer any tokens available, it returns what? Fill in the blank. It's a pointer. What is the only pointer that indicates something abnormal happened? Null, right? So it returns null when it's done, okay? Careful. There we go. The first time you call strtoke, you pass in the string. You want to tokenize. However, every subsequent call, you pass in null to continue processing the same string. And that's because of the way that it works. All right. If you didn't pass in null on the subsequent one, it'd be like saying, okay, you mean you want to go, you want to process that other string over there. Okay, I'll start on that string. Null, null, null. I'll keep working on that string. The second you pass me something that's not null, I then process that new string. And if I'm always passing in the same string, it always starts back at the beginning. Don't worry, I'll visualize this here in a second for you. Okay? All right, so let's come over here and let's go ahead and process this CSV data. I'm going to need a character pointer representing a token, not tokens, but one token. And I'll call strtoke on CSV data. And I want a delimiter of a comma because it's CSV data. If this were TSV data, I would say, well, no, I want a tab instead. Right? There we go. Now let's see what the contents of token is, or by simply just printing it out. Oops, printf. All right, token is equal to %s and the line token. All right. Oh, lecture there. There we go. Now I'm in the right class. GCC demo. There we go. All right. There's the title of the book. All right. Note here that I am the one going to the next line. There is no end line character in this token. And so when I print it out, I'm going to the next line just to format it. All right. Let's try calling it a second time. Now this is going to be wrong because I am passing in the same string. Consequently, what is that pointing to? It's pointing to the C, the first character of the original string. So if I try to do this a second time, it's going to give me the exact same token. All right? Let's change that so that on every subsequent call, I'm passing in null now. All right? That means this is a signal. Work on the same string that you just did, which has the next token of T for Terry. All right? So run that. Now I've got Terry. Let's keep going. There are 2 tokens, 3, 4, 5 tokens. GCC. All right, I got them all. All right. There's Color of Magic, Terry, Pratchett, 1983, 3.98. What if I did this one more time? Yeah, I might crash. If it returns null, and if I dereferenced it, then of course Bret Hart would come out of my computer and hit me over the head for it. But I'm not dereferencing it. I'm passing it off to printf, which sees, oh, null? I'll go ahead and format that for you. We did this before in an example or something, right? Print array, right? And if we got that, then we printed out null or something, right? They're doing the same thing that we were doing. So let's take that away, showing you that indeed it is null. But should I be copy, paste, copy, paste, copy, paste, copy, paste? Probably not. What could I do instead? A loop. Now, looking at this data, you know that there are 5 tokens. So you could write a for loop that went 1, 2, 3, 4, 1, 2 for each one of those tokens. What if I didn't tell you how many tokens there are in that string to begin with? Would a for loop be appropriate? Yeah, let's go with a while loop instead. While some condition, I will print out the token and then do something else. All right, I'll just leave it like this for a second. Oops. All right. So how do you know that you still have a token that needs to be processed? Again, it's going to go to the first one, second one, third one, fourth one, fifth one. Right. Yep. So what am I storing those tokens in? Token is here. How about this logic? While token is equal to null, that's my stopping condition. What's my continuation condition? Not equal to null. There we go. And I need to make progress towards my terminating condition, which means I need to get the next token at the end of this loop. All right? Just like when we did a while loop to go from 1 to 10, the initialization, right here. The continuation, right here. The I++ to make progress towards 10, right here at the end. Okay? Let's see if that works. Yeah, it does. Now let's look at what this does over here in Python Tutor. Again, they should call it C Tutor or whatever. They should have a different website for it and divorce itself entirely from... Oh, all right, fine. What's wrong? Where is all this fancy stuff that I'm using right now? In the string library, right? There we go. Now it should be all right. Right? Come on. There you go. All right. All right. So there's my CSV data. Color of magic, blah, 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 all the way to the end there. Right. Note what's at the end here, the null terminating character. Now let's watch this. I've only got one pointer here. That pointer is going to change. On the first call, what is it pointing to right now? That first token. Right. What else just happened? Might have been too fast, but let me go back and forth on this. What else is changing? A, B, A, B. Right. For those of you that don't wear glasses, you get you get this experience at the optometrists, right? They give you one. Is it worse? Or A or B? A or B? A or B? And you never know which one's better because they go back and forth too fast, right? Let's slow down. All right. So, what happened? What else? Yeah. Null character where? What was there before? The delimiter, right? Where the comma was. And so remember that promise that there is no const in front of it might change your data? Well, it is changing your data. How? By placing a null terminating character where that delimiter was. Why? Because the next time you call strtoke, which I'm about to do here, this pointer is going to be updated to the next token here. And then what happens to the next delimiter? That's going to be the null terminating character. There it is. Right. This is how it works. It starts jumping, leapfrogging from delimiter to delimiter to delimiter to delimiter. Right? And unfortunately, I can make this really small, and you'll see that it's going to leapfrog to the next one, and then all the way to the end. Right? But otherwise, that wouldn't all fit. Okay? All right. So that is how we can process that file. Just for fun here, what if I offered other delimiters? For example, A. Right? A. My delimiter is now a lowercase a. What is the first token? I don't see any lowercase a's until then. Color of M. Right? And where's the next one? The A in Pratchett. So if I were to run this, I'm going to get completely different tokens here because I no longer am using the comma as my token. I can use multiple things, A and a comma here. Or maybe, I don't know, 1. There we go. 1. Let's figure out what this does. Right, there we go. Color of magic, just nonsense basically. But I chose those to show you, well, what happens right here? There are 2 delimiters. There's now a comma and a 1. But is there an empty token in between them? Nope. So the behavior of this is if it sees the same delimiter multiple times, let's go ahead and show you with just the comma here what happens, right? Comma here, if I've got empty, no, just comma, there we go. If I've just got empty tokens there, it ignores them, right? So that's another observation there. Why would you have this in your data? Well, it is actually quite common, right? Because I don't know who the publisher was in 1983. I don't know who the editor was, right? Or whatever data you have, if it's missing, it's generally empty data. Now, if you want to explicitly say that there was empty data, you could put a keyword in there like null, like we've been doing, or uppercase NULL, right? Or missing, or an empty string. Here's a way of doing it. Can I do it that way and see though? Those are reserved, right? So I would have to do what? Escape it, and now you're back to square one of, all right, if you really want to do this kind of data, bring in a library to do it because that's way too confusing, right? All right, so let's go ahead and get rid of all of those. Excellent. All right. Let's see. Okay. So other observations, right? Again, delimiters are changed to null terminators, right, by strtoke, right? So be careful. Solution, again, what was our solution? Create a deep copy. Deep copy if you don't want your data deleted or messed with, right? That should say solution, not solution. Right? There we go. One other observation I want to make here is that tokens are not permanent. Here, I'll put permanent there in quotation marks. Okay. And what I mean by that is, what if I wanted to save these tokens off into something else, right? For example, let's unroll this, I guess, maybe. And go back to our, actually, before I do that, let me go ahead and grab this and put it in the notes for you because we're going to muck this up and destroy it. There we go. So it's in the notes now. I'm going to go ahead and unroll this while loop here. some quick key I just learned. All right, let's go ahead and get rid of that. There we go. That's what I want. 1, 2, 3, 4. All right. Actually, let's name these all different things. Token 1, token 2, and make sure that the subsequent call here is null. All right. Token 1, 2, 3, 4, 5. 3, 4, and 5. All right. Now, at the end of all, now you might be thinking, oh, okay, well, you're saving off these 5 tokens into these 5 other variables here. All right. Fine. Let's go ahead and say strcpy into CSV data, the next line of data. And I'm going to copy that many times. All right. Not too many, though, I guess. What do I want? Space, that's too many. Let's just go with that much right there. All right. Now, is my token data safe? Token 1, 2, 3, 4, and 5? Let's find out. I'm going to go ahead and print all my token data. Printf token 1 is equal to %s and token 1. Token 2, 3, 4, 5. 2, 3, 4, and 5. I'm not even sure if this is going to work. It's such a bad idea. And we'll understand that why when we look at the visualizer again. Huh, there. Oh, I should have put an inline character in there. And. There. Is that my Terry Pratchett data? No. Why is it all messed up to this new string right here? Right. Let's get rid of a couple of these question marks and see if we can at least save some of our data. There we go. Oh, if I didn't have all those question marks, at least I would have saved 3.98. Right. Let's put this into Python tutor again. Edit this. All right. And visualize this once again. Go back to 100% there. Reset it. There. Okay. Run this. Now, instead of using the same pointer over and over again, I've used now 5 pointers. But what are they pointing to? The original CSV data. On my next line, I'm about to change the contents of that by calling strcpy. Now what about all my token data? Token 1, 2, 3, and 4, and 5. Are they pointing to the original data anymore? Nope, it's been changed. Right? So be careful, right? Tokens are not permanent. If you need to, you can copy them over into a different string. And what kind of copy would that end up being? Oh, deep or shallow? Deep copy. In fact, what I was doing here is basically a shallow copy. It is a reference to the same data. I want 5 different pieces of data here. Right? So let's do that as an exercise. I'm going to go ahead and restore the code I had before. Let's go ahead and get rid of this bad code here. I don't want to copy the bad code to the notes, but it'll be in the video, right? All right. So now instead of printing them, what I want to do is I want to copy them over. All right. Here's I want to copy each token over into an array of strings. Right? So I want the first row to have Color of Magic, the second one to have Terry Pratchett, 1983, etc. Right? So I want an array of 5 strings. How can we do that? This is very, very similar to what you're doing right now in length split. If instead of splitting along commas like I'm doing here, if I split along strings of size 4, what would it look like? COLO, right? And then the next 4, that one. And then the next 4, that one, right? So how are you doing length split? Length split is storing its data how? What does length split return? An array of strings, which would be a two-dimensional array of characters, char star star, right? And I'll call this one tokens because there are going to be 5 of them. I'll make a call to malloc, char star star malloc, right? Size of, fill in the blank here for me, times 5. I'm just going to go ahead and hard code 5 here. Right? Actually, let's put in n is 5. Right? And I'll put n there. If you didn't know how many tokens there were up front, you of course couldn't program it like this being 5 all the time. Sometimes it'd be 7, sometimes it'd be 4, sometimes it'd be 1. Right? So what would you have to do? You'd have to go through and count up the number of tokens that you actually need first. Right? Now in length split, you can do that by just doing simple math. Right? If it's of length 15 and each one is a size 5, then you're going to need 15 divided by 5, 3 of them. Right? But in this case, what determines my token? The delimiter. Go through and count up the number of delimiters. 1, 2, 3, 4. Is that the number of tokens? Nope. Because if you have 5 fingers, how many gaps do you have in between your fingers? -1. So add 1 to it. Right? We won't do that. I'll leave that as an exercise. But what should the size of be? Should it be a single character? Well, the tokens is a double character, which means that it's a pointer to a pointer. Therefore, I need pointers pointing to each one of those rows. So char star. Right? Same pattern as an integer array. Right? Okay. I will establish an index variable here, starting at 0. Now, before I had a print statement here. Right? I got rid of that. My processing now is going to be copying whatever token this is into the ith array. So I'm going to go ahead and copy into tokens of I token. Right? Well, that should just be an strcpy, right? strcpy tokens of I into token. Right? Is that enough? Yeah, well, strcpy will take care of that for you, right? strncpy might not, which is why if you're using strncpy in your length split, you need to make sure that you're doing that. Right? What did I ever? Let's go ahead and put this into Python Tutor and see what it visualizes. Right? I certainly set up the array of pointers. But I only made one call to malloc, right? There we go. All right, so what are you complaining about? Oh, okay. It's showing me what the error is. I didn't want you to be that good. Come on. So spoiler here, it's complaining about this. It's an uninitialized value. So this is, I've created my pointer to my array, but have I initialized each row? Nope. So let's come back over here and fix it. I really wish that it would, you had a mode or something to say, no, I'm trying to do something stupid, please let me do it, right? But apparently it's not going to work, right? Yeah, an idiot mode, yes, good. Tokens of I, points to, ... what? What is that? What does the first row point to right now? Nothing, right? It's uninitialized. That's what the Python tutor was telling me. So before I copy it over, if I'm doing a deep copy, what do I need to do? Malloc it, exactly. Tokens of I is going to be a direct call to char star malloc. Now here's size of char, right? Regular old char. How many of them do you want? N? Well, N is only 5, so that would mean 1, 2, 3, 4, 5. But I need that many. On the next token, I need that many. On the next token, I need that many. It depends on the string. So it should be strlen of token. Right? But that's still wrong. What am I missing? +1. Always remember your +1. Right? There we go. All right. Even if you're invited to a party and don't have anybody to go to, still saves +1 so that you can get 2 meals out of it or something. Right. There we go. All right, now we can A dot out this. Of course, I'm not printing anything. So let's go ahead and do it now. For int I equals 0, I is less than n, I plus plus. Right. Printf tokens sub %d is equal to %s and the line I, and then tokens of I. And we'll see that we are getting the same values as before, that we're just printing out these 5 pieces of data. Oops. Oh, what did I forget? Only the first one worked. And we got the last token there. I set up my index variable, but what didn't I do with it? Yeah, I never incremented it. I plus plus. I was saving that in the back of my mind, but I forgot about it. Right. There. Now let's put this into Python Tutor and see what the difference is. Right. They're never gonna stop with that. What? Oh, I didn't copy over the first line. Sorry. So, oh, where's my edit button? Oh, have I been throttled? No way. Oh, come on. This. Oh, sorry. Yeah, that's right. Tokens. No, token would be. This is correct. But no, they took away my edit button. Tokens is going to be the array of strings. No, it's going to be token, because that's the temporary pointer. All right, edit this. All right, maybe I just donked it out or something temporarily. Hopefully they're not going to make me start paying for this. Otherwise, this tool. I know a way around it. Just open it up in privacy mode. Open it up in Tor, and it'll be fine. Come on. It works over here. All right, so Valgrind. Are we doing something wrong? Yeah, well, that's just memory leaks. We don't have any invalid reads or writes. What are you complaining about, man? All right, edit this code. Oh, okay, I got rid of the string include string.h. It got rid of it when I refreshed. Come on. All right, that's good enough. All right, there are still warnings, but at least the visualization will work now. So there's color of magic, right? There's the pointer to the char. There's token. Tokens over here, that has 5 pointers that have not yet been initialized, right? Let me go ahead and zoom out here so that you can actually see it. Right? Now on the first iteration here, we've got that first token. That's our call to malloc. That's going to set up exactly as much space is required to hold color of magic with a null terminating character at the end. Now I will zoom back in so that you can see that it is color of magic right here. Right? All right. Next one, we'll initialize the second token and the second row of that array of pointers. Right? Third, fourth, and fifth. Now, they are completely separate. Here's the original data over here, which has been changed because of strtoke. But now here are my tokens stored in a 2-dimensional character array, or an array of pointers, or an array of strings. Right? Hopefully this exercise here, I'll put the code in the notes and then commit it later tonight when I get home. But hopefully that'll also help you towards your length split. Right? Okay. Any questions on this? Otherwise, the last thing for today would be a review of string comparisons, right? So way back at the beginning, when we introduced the equals equals operator, we said you can use this for numbers, doubles, integers, even characters, but you cannot use it for strings. And we didn't really talk too much about strings at that time, but now we need to revisit it, right? To properly compare them, you need a comparator function, and that's going to be strcmp. Most of you did this in your lab on Tuesday, right? In fact, I think that the lab handout said, here's strcmp, here's how it works. It takes two strings as arguments, A and B. If the contents of A come before B, it returns something negative, right? Basically, that's the idea that A is strictly less than B, right? If the contents are equal, I should say, right, then it returns 0. And if the contents of B come before A, in other words, they're out of order, then it will return something positive. Right? Don't read anything into the magnitude of that negative number. It could be negative 42, it could be negative 1, it could be negative 1 billion. Right? It doesn't matter. The negative is what is important. Right? That says that this string comes before that string. Right? If they're the same, then it's going to be 0. But if they're out of order, then it returns something positive. The way that I like to look at it is like the number line. You've got negatives over here, 0, positive, right? You've got A and B, right? And if they're in order, then it's over here. If they're equal, then it's here. If they're out of order, then you've gone to the positive side, right? I don't know if that's a useful visualization or not, but whatever, right? So let's go ahead and create two variables here. And this is char A, right, is equal to I don't know, apple, right? And char B. Actually, let's keep it simple at first. Apple, banana. Right? And let's go ahead and capture the integer value here. Result is equal to strcmp of A and B. Now, which one comes first, apple or banana? Apple. So printf result is equal to %d and the line result. So for this one particular example, what would you expect as an output? A negative number. Why? Because A comes before B, right? So negative value, and it's a negative 1. Okay? If right? Good? All right. What if I swap those around? Apple and banana and apple. Those are out of order. So what would you expect it to return? Something positive. In this case, 1. Right? Don't read anything into that. That's implementation specific. All right. Apple and banana. Capital A. The difference there is a capital A. Let's find out. Negative 33. Are they in order or out of order? Negative is in order. Negative, positive. So cross your hands when you think about it like this. They are out of order. Positive, right? Plus, if that helps, right? Negative, positive, 0. They're the same, right? So which one comes first here? Apple, right? What about, let's go with apple and banana. Big B, banana. Are they in order or out of order? If you were to look this up in the dictionary, which one comes first? Apple. Positive. Banana comes first with a big B. Why? Yeah. ASCIItable.com. What is it doing? It's finding that capital B before it finds that lowercase a. Right? This is not alphabetical order. This is what's called lexicographic order. Right? So this uses lexicographic order according to the ASCII table, right? Not alphabetic order, right? So yeah, the dictionary is great, right? Banana would come after apple. It doesn't matter if you've got a big B or a little b in front of it, right? But this is not a dictionary, right? It's lexicographic ordering, and consequently, all capitals come before all lowercase values. Numbers come before letters. So if I were to do something like this, apple and 1, 2, 3 apple, which one of those comes first? 1, 2, 3. And so therefore they are out of order, and it would return something positive. Okay. What about 9 and 123? Pure numbers. If you were to naturally order these in ascending order, right, then you would say 9 comes first, right, because it's less than 123. But lexicographic order, which one of those comes first? The 1, right? Why? Because, where's my ASCII text table? The character 1 comes before the character 9. Right? GCC this, run it again. Come on, there we go. Result. So something positive, they are out of order. Right? All right, let's make it apple and apples. Which one of those comes first? Apple, because it's shorter, right? So it gets down, okay, the first 1, 2, 3, 4, 5 letters are the same, and then it gets down to the last letter. Well, what's the last letter on this string? The null terminating character. What's the last letter on this string? S. Where's the null terminating character again? The very first one. It always comes first. So shorter ones come first, all right? Be careful. Comparing them, it means lexicographic comparison, not alphabetic, not numeric. It's according to the ASCII text table. Okay. All right. I've got shorter. So some observations here, I guess. Shorter strings come before longer strings. Let's move back over here, all right, and see if I can copy paste that. There. Shorter strings come before longer strings with the same beginning. Apple is less than apples. Uppercase letters come before any lowercase letters. So banana comes before apple. Numbers also come before letters. So 123 is less than apple. Numbers follow the ASCII text table. So 123 is strictly less than 9. These are all lexicographic orderings. Okay. There is another version, alternative, str case CMP, which ignores casing, right? That is, A and A are the same. Now that still doesn't get you dictionary ordering because you still have numbers and other letters and stuff like punctuation and stuff like that. But for example, if I did apple and apple, there we go, str case CMP. Now, what would the result here be? We're 0 because they're the exact same content, ignoring the upper and lower casing. All right. All right. Any questions? All right. Then what's the spread on UCLA? Hopefully, we're favored, right? Oh, probably. So hopefully we will become bowl eligible here with a nice win. Otherwise, enjoy your weekend.